All right, so before I get started on today's notes, I did have somebody in my office hours yesterday did ask me a question, and I thought it was a good question. So let's go ahead and go to my extra piece of paper here, and I'm going to do problem number 10 for you. All right, so on problem number 10, okay, it wanted us to factor completely, and it was 3r to the 6th minus 11r to the 5th minus 20r to the 4th. All right, so since we have to factor completely, again, what I suggested is you look at the last one there. If it has something, we can pull all of that out and make adjustments. So if I factor out an r to the 4th, all right, what I'll be left with is 3r squared minus 11r minus 20. All right, now that one is a quadratic that we don't have a coefficient of 1 on the r squared. So remember, one of the things I suggested to you was that we go ahead and do our diamond and our box. So remember, when I do my diamond, I take the first and the last term and I multiply them, which will give me negative 60r squared. Then I take the middle term and I put that one down below. All right. So now we were talking about this as during the office hour, and I said, okay, what are some factors of 60, and see if we can get it to equal negative 11. So we kind of just played around here, and I said, what about 6 and 10? Well, you know that's not going to work. And then I said 5 and 12, because those both, when I multiply them, do add up to 60. And we just kept saying, well, that's not going to work either. So then I suggested, okay, why don't we try a factor tree and see if we can see something from there. So on 60, remember, I'm just going to take whatever multiplies to that. So I can have 6 times 10. And then I'm just going to keep breaking it down until I get prime numbers. Well, 2 and 3 are prime, and 5 and 2 are prime. And I wrote it like that, and right then we kind of saw that 3 times 5 is 15, and 2 times 2 is 4. So in that case, it was negative 15r, and then we had 4r. Okay, so when we did that, after we did that, remember, I told you to make a box. And in the box, again, I don't care how you do it, but you want to put your first and your last term. So we started with 3r squared and negative 20 in one diagonal. Then we want to put our two answers in the next one. So we ended up with negative 15r, and we had 4r. And remember, after that, I told you to go ahead and factor the boxes. So I started with this one right here. What can I factor out? I can factor out a 3r. And then again, 3r times what equals 3r squared would tell me that's r. 3r times what equals negative 15r. And you would tell me that would be negative 5. And then again, r times what gives you 4r? You would tell me 4. And as it checked, is negative 5 times 4 equal negative 20? And you would say yes. So now we see that to factor it completely, you should have had r to the 4th, 3r plus 4 times r minus 5. So that was our answer to problem number 10. So let's go ahead and get started with today's lesson. And on today's lesson, we're still going to keep continuing factoring polynomials. It's day 2. We're going to do just a little bit more on it. And so an expression of the form au squared plus bu plus c, where u is an algebraic expression, is said to be in quadratic form. The factoring techniques you have studied can sometimes be used to factor such expressions. So example 4, factor each polynomial completely. The first one is 625x to the 8th minus 256. So my question to you, does it look like a difference of two squares? And if you look at it, we do have a minus sign there. And we do have, well, it is. I'll just put it there for you, okay? Because I know that 625 is 25 times 25. So I can write that as 25, and then x to the fourth, remember, a power raised to a power. So I'm going to put x to the fourth, and all of that is going to be squared, all right? And I know that 256 is 16 times 16. So as you can see, it is a difference of two squares. So if it is a difference of two squares, then remember I can write this as 25 x to the fourth plus 16 and 25 x to the fourth minus 16. All right. So now this one right here, this last one, this is also a difference of two squares. All right. So on that one there, the first one stays the same because we have a plus sign there, so we know it's not a difference of two squares. But remember, 5 times 5 is 25, so we can write this as 25x squared, and 16 is 4 times 4 plus 4, and 5x squared minus 4. And we are done with that one. Okay. B, we have 2x to the 13th plus 10x to the 9th plus 8x to the 5th. So again, look at this last one here. We have x to the 5th, so we're going to factor out that common monomial. I don't know why I'm putting that. Factor out common monomial. So when I factor that out, and also look, looks like I can factor out a 2, because 2 times 5 is 10 and 2 times 4 is 8. So I can factor out 2x to the 5th. And then what I'll have left is 8x to the 8th, plus 5x to the 4th plus 4. Okay? So now this is in quadratic form. Right? So one way to look at it, if you're not sure, is use substitution. Remember, a quadratic is x squared plus ax plus b or c. All right, whatever you want to think about it. So if you don't see it, use substitution. I'm going to let u equal x to the 4th. If I let u equal x to the 4th, then I have u squared plus 5u, remember u is x to the 4th, plus 4. So if we look at that one, then we can say, oh, that's kind of easy because, again, the coefficient is 1. So again, I'm going to put a u here and a u here. Since this one's plus, and I look at that one, it's plus, so they both have to be plus. How about our factors of 4 that add up to 5? You would tell me 1 and 4. Okay? But remember, what we did is we let u equal x to the 4th. So, but u is equal to x to the 4th. So if I replace u, I'm going to have x to the 4th plus 1. I'm going to have x to the 4th plus 4. All right? So then that, we'll just go ahead and put the answer over here, means that we're going to replace that with 2x to the 5th, x to the 4th plus 1, x to the 4th plus 4. And then we are done with that one. Okay. Now, we didn't really talk about the remainder theorem. That was in the previous section, but we decided to just tell you about the factor theorem because the factor theorem will let us know if something is a factor. So a factor would be when we get a remainder of 0. So the special case of the remainder theorem is the factor theorem, which states that the polynomial f of x has a factor x minus k if and only if f of k is equal to 0. All right. So on the first one here, we are going to look at it, and we are going to determine whether x minus 3 is a factor of f of x is equal to x squared plus 6x minus 12. Okay? So sometimes it's easier to use direct substitution. Sometimes it might be better to use synthetic division. You could use synthetic division for both of them, but on this one right here, I would say let's just go ahead and use direct substitution. So find f of 3, because remember, it's x minus 3, which is x minus k. So in this case, k is equal to 3. So we're just going to do it by direct substitution. And so I'm going to put f of 3. Remember, when I put it there, f of x, x is now equal to 3. So wherever I see x, I'm replacing it with 3. All right. 3 squared is 9. 6 times 3 is 18 minus 12. And that will give us 15. Now remember, the factor theorem states that it is a factor if it equals a 0. So f of 3 does not equal 0. So x minus 3 is not a factor. Okay. Now, sometimes it looks a little rougher. On this one here, determine whether x plus 3 is a factor of f of x is equal to 2x to the 4th plus 10x cubed plus 11x squared minus x plus 6. Now that one kind of looks nasty, but if it looks difficult, go ahead and just use synthetic division. So if we recall what I told you to do before, okay, now remember, it's x minus k, right? And we have x plus 3, so that should be x minus a negative 3. So our k is now negative 3. Since our k is now negative 3, remember, I put that on the outside, okay? And then I put the coefficients. So I have 2, 10, 11, negative 1, and 6. Remember, I told you to put a bar in between, because the last one will be our remainder. And we're going to go and do what I told you to do before. So we bring the first one down. Negative 3 times 2 is negative 6. Remember, 10, we're adding 10 plus negative 6 is positive 4. Negative 3 times 4 is negative 12. Adding them, we'll get negative 1. Negative 3 times negative 1 is positive 3. Adding them gives me 2. And negative 3 times 2 is negative 6, which gives us 0. Remember, I just told you the last one is the remainder. So since it is a factor, so since f of 3, negative 3, excuse me, is equal to 0, x plus 3 is a factor. So a couple of the questions will just ask you if it's a factor or not, but then the next ones will ask you if it is one, and if it is one, to factor completely. So when it says show that it is, they're really telling you that it is. You just need to show it is, all right? So show that x minus 2 is a factor of f of x equals x to the fourth minus 2, x cubed plus x minus 2, then factor completely. So again, what we have to do is we have to show that it is equal. The remainder is equal to 0. So in this case here, I'm just going to go ahead and use direct substitution like I did before, okay? Just because it's 2, so it's kind of a simple one. So I'll have 2 raised to the 4th power minus 2 times 2 cubed plus 2 minus 2. All right, 2 to the 4th is 16. 2 cubed is 8. 8 times 2 is 16. So I'll have 16 minus 16. We had plus 2. We have minus 2. As you can see, that does equal 0. So x minus 2 is a factor. Now remember, when I say it's a factor, it is going to be part of our answer. All right? So now, again, I like using synthetic division. I think that's the easier than dividing the other way. So I'm going to now use synthetic division. Now, what I like about this one here is remember, so it's our k is going to be 2, so we're going to put that on the outside. Now remember, on this one here, I have a coefficient for x to the 4th, which is 1. I have one for x cubed, so that's negative 2. Notice we don't have an x squared term, so what am I supposed to put there? 0. Then I have 1, and then I have negative 2. All right, so now if we do this again, I bring the first one down. 2 times 1 is 2. If I add those together, negative 2 plus 2 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 1 plus 0 is 1. All right. And then I have 2 times 1, which is 2. And then I have a 0 there. So now remember, this is my remainder. So now it is 0. So remember, on this one here, this is my constant term. This is my x term. This is my x squared term. This is my x cubed term. All right. So now our f of x from above, we can now factor it to be x minus 2 times x cubed plus 1. But remember that x cubed plus 1, I can write 1 as 1 cubed, so this is a sum of cubes. And remember from yesterday, you might probably want to check your notes again. We would look at that, and we're going to have, we can simplify this to x minus 2. Remember, I told you on this one here, on a sum of cubes, you can write it as x plus 1. Then we're going to take our first term and square it. So that'll be x squared. Then I'm using the subtraction. Remember, I'm going to take my a and my b. So x times 1 is just x. And then I square the last term, which is plus 1. And remember, that one shouldn't be factorable anymore since it is a sum of cubes. So I'm all done, and you're all done. Time to do your homework. Thank you. Bye.